let's start the lesson for today's math class. And today's math class is going to be about adding and subtracting fractions with like denominators and simplifying. So adding and subtracting fractions with same or like denominators, and of course, and simplifying if we can. Please make sure you put the date on the top of your notes. Okay, let's start. We always like to start with some examples here. All right, let's start with 1/5 plus 3/5. Now, don't make that common mistake that a lot of people make when they add fractions. Okay, the goal is we want to make sure that the denominators are the same so that we can easily add or subtract them. In this case, the denominators are already the same. The denominators are both 5. So that's work we don't have to do. It's already done. What we do need to add, though, is the numerators. 1 plus 3 is 4. And my denominator is not 10. We never add the denominators. Never, never, never add or subtract the denominators. All right, so I'm going to keep that denominator the same, which is 5. Now, that as you look at our heading, we need to simplify if we can. Can we reduce 4/5? If we put that into the division ladder, 4/5. As we've learned earlier, when those two numbers are one digit apart, 4 and 5, there isn't going to be a factor that they share that can be divided into both of them. All right, so we are done. We cannot reduce 4/5. All right, let's try another one. 4/8 plus 2/8. We start with our numerators. Actually, let's look at our denominators. Are they the same? Yes, our denominators are already the same. They are both 8. So let's look at our numerators. 4 plus 2 is 6. And then our denominator stays the same. That is 8. Okay, can we reduce this problem? Well, let's see. Let's plug them into our division ladder. 6 and 8. And let's start with 2. Can 2 go into both of those numbers? Yes. And we know that because they are both even numbers. What times 2 equals 6? We know that that's 3. What times 2 equals 8? That's 4. And these numbers, just like 4 and 5, these numbers are one number apart. So they do not share that greatest common factor. We cannot reduce them anymore. So our answer for this problem is 3/4. 6/8 can be reduced down to 3/4. Let's do another example. 2/10 plus 4/10. Okay, first question I need to ask is, are my denominators both the same? In this case, yep, they are both the same. They are 10. So now I can start with my numerators. 2 plus 4, once again, is 6. That hasn't changed from our last problem. And our denominator is now 10. Okay, let's see if we can reduce 6/10. Let's plug it into our division ladder. Can 2 go into both 6 and 10? And we know that answer is yes, because they are both even numbers. So what times 2 equals 6? 3. What times 2 equals 10? 5. Okay, now we're left with 3/5. Can we reduce 3/5? Okay, let's use our division ladder. Let's use our divisibility rules. Can 2 go into both of those numbers? No, because they are not both even numbers. Neither one of them are, in fact. Can 3 go into both those numbers? Well, let's check. 3 can be divided by 3, so that will work. How about 5? Is there a number I can multiply 3 by that will give me 5? No, there is not. So our answer is 3/5. 6/10 can be reduced to 3/5. This next example I want you to try on your own, and then we're going to do some subtracting. 7/12 plus 1/12. Please pause this video, try this one on your own, and start playing again when you're ready to check your answer. All right, let's check your answer, and I'm going to go through this pretty quickly. All right, our denominators are the same, so let's look at our numerators. 7 plus 1 is 8. 8/12, and I think I can reduce that. I'm going to double check. Let's put that into the division ladder, and I know 2 goes into both of them. 6 times 2 equals 12. All right, 4 and 6, those are both even numbers as well, so I know 2 goes into both of them. 2 times 2 is 4. 3 times 2 is 6. Now I'm left with 2 and 3, which are both one number apart, so there is not going to be any further reducing needed. And my answer is 2/3. So if you got 2/3, you are correct. All right, let's go on to some subtracting. We're going to do it the same way as adding. The same way. All right, on your papers, let's put 11/12 minus 5/12. Same as an addition problem. Only we're not going to be adding, we are subtracting. So don't confuse yourself when you get your assignment. Okay, our denominators are the same, so I can start with my numerators here. 11 minus 5 is 6. My denominator stays the same, which is 12. Some of you may know right off the bat what 6/12 reduces to. And that's good. That means you're remembering things and picking things up already. If not, that's okay. We're going to plug it into the division ladder. Can 2 go into both of these numbers? Yep, because they are both even numbers. What times 2 equals 6? That's 3. What times 2 equals 12? That's 6. 3 and 6. Let's try that. Can 2 go into both of those numbers? No, because they're not both even numbers. Can 3 go into both of those numbers? Yes, 3 can go into both of them. 1 times 3 is 3. 2 times 3 is 6. And once I see 1, I am done. So my answer to this problem is 1/2. And good job to you if you got that right away once you saw that 6/12. Nice work. All right, let's try 13/15 minus 10/15. And I want you to pause this video, try this on your own, and turn this back on when you're ready to check your answer. All right, let's see if you're right. Our denominators are the same, so nothing I have to do there. 13 minus 10, 3. My denominator is 15. Can I reduce 3/15? Well, let's check if you're not sure. Some of you may know this answer right away, and that's great. 3 and 15. Can 2 go into both of these numbers? No, neither one of these numbers are even. Can 3 go into both of these numbers? Okay, well I know 3 can go into 3, and I know 1 plus 5 equals 6, and 6 can go in, or 3 can go into 6. So the answer is yes. 1 times 3 is 3. 5 times 3 is 15. Oh, I see a 1. I know I am done with my division ladder. So 3/15 I know can be reduced to 1/5. Once you've completed these notes and you understand everything, you can let your teacher know you are ready to start your assignment.